James Webb just captured something impossible. The Milky Way should have held on to it, but it didn't. Gravity should have won. The galaxy should have kept it trapped. The stars, the dark matter, and the invisible pull of hundreds of billions of suns, all of it should have been enough. But Webb's view points toward a terrifying possibility. Something was moving fast enough to escape. Not orbit, not return, but escape. A one-way path out of the galaxy and into the black space between galaxies. And if that is true, then something inside the Milky Way did more than move a star. It broke the galaxy's grip. This matters because objects that escape the Milky Way carry the story of how they were launched. Some hypervelocity stars may be produced when a binary star system passes too close to a supermassive black hole. One star is captured, and the other is flung outward at extreme speed. Hubble observations of the hypervelocity star HVS-3 supported a possible origin near the Milky Way center. But newer research also suggests some hypervelocity stars may come from outside the Milky Way center, including possible origins linked to the Large Magellanic Cloud. That makes the mystery even bigger. The runaway object may not only tell us about our galaxy's black hole, it may reveal hidden massive black holes in nearby galaxies, too. If Webb is helping us see the dusty regions where these stories begin, then the object leaving the Milky Way is not the end of the story. It is the trail back to whatever launched it. The first terrifying idea is this: the Milky Way can lose stars. Not planets, not dust, not small rocks drifting at the edge, but stars, entire suns, objects so massive, so bright, and so gravitationally important that they feel permanent. But some of them move so fast that even the Milky Way cannot keep them. They do not orbit calmly. They do not circle back. They do not stay bound to the galaxy that created them. They escape. And if James Webb captures a clue pointing to something leaving the Milky Way, then the story is not really about the escaping object. It is about the force that launched it. Because stars do not just walk out of galaxies. Something has to throw them. The Milky Way is not weak. It contains hundreds of billions of stars, enormous clouds of gas and dust, dark matter, and a central supermassive black hole called Sagittarius A star. NASA describes Sagittarius A* as roughly 4 million times the mass of the Sun. So, when something begins moving fast enough to escape all of that, astronomers have to stop and ask, what could overpower the gravity of an entire galaxy? That is where hypervelocity stars enter the story. These are stars moving at extreme speeds, sometimes fast enough to escape the Milky Way's gravitational grip. NASA has documented cases where Hubble observations supported the idea that a hyperfast star was kicked away after a violent encounter involving the galaxy's central black hole. That is the first clue. A runaway star is not just a runaway star. It is crime scene evidence. Its speed is evidence. Its direction is evidence. Its age is evidence. Its path through the galaxy is a trail pointing backward to something violent. And that is where Webb becomes important. Webb does not need to see the star leaving the galaxy like a movie camera watching a rocket launch. That is not how astronomy works. Instead, Webb can reveal regions where these violent stories may begin, especially dusty, crowded regions near the Milky Way center where visible light telescopes struggle because gas and dust block the view. In 2023, NASA released a Webb image of Sagittarius C, a star-forming region near the Milky Way center. Webb's NIRCam revealed a 50-light-year wide view packed with an estimated 500,000 stars and features astronomers had not fully explained. That is not just a beautiful image. That is a battlefield. A crowded stellar nursery near one of the most extreme environments in our galaxy. Young stars, dense gas, magnetic fields, radiation, outflows, dust, and, not far beyond that region, the gravitational monster at the center of the Milky Way. This is the kind of place where normal motion can become violent, where a star's path can be changed forever, where a system that should have remained bound can be torn apart and rewritten by gravity. But here is the conflict. A star leaving the Milky Way does not come with a label. It does not glow red and say, "I am escaping." It may look like any other point of light until astronomers measure its motion, distance, and speed. Only then does the truth appear. The star is not simply moving. It is fleeing. And once that happens, the entire question changes. Scientists do not ask only, where is it now? They ask, where did it come from? Because the path of a hypervelocity object is like a bullet trajectory. Trace it backward, and it points toward the gun. Maybe the gun was Sagittarius A star. Maybe it was a supernova in a binary system. Maybe it was a close encounter with another massive star. Maybe the object did not even start where we think it did. Every possibility tells a different story about the Milky Way's violence. And this is why the title matters. Something leaving the Milky Way sounds like a single object, but the real discovery is much bigger. It means the galaxy is not only building stars, it is ejecting them. It is launching some of its own children into the darkness between galaxies. And once a star leaves, it may never return. It will travel into intergalactic space, where the night is not just dark. It is almost empty. No familiar constellations, no spiral arms around it, no stellar neighborhood, just a lonely sun moving farther and farther from the galaxy that failed to hold it. That is the consequence. If Webb helps expose the environment behind one of these cosmic escapes, then we are not just watching an object leave. We are watching gravity become a weapon. So the first layer is clear. The Milky Way should have held on to it, but something gave the object enough speed to break free. And the next question is the dangerous one. Was the launcher hiding near the black hole at the center of our galaxy? At the center of the Milky Way, there's a monster we cannot see directly in ordinary light. Sagittarius A*, a supermassive black hole, is a point of extreme gravity buried inside one of the most crowded and dusty regions of the galaxy.